Explain Fourier's law. Fourier's law shows that a periodic signal can be decomposed into multiple frequency components. This law makes it easy to handle mathematically complex functions and plays a very important role in signal processing. A periodic signal is a signal that is repeated periodically. For example, periodic signals such as sine waves or square waves can be broken down into several frequency components. Fourier's law allows these periodic signals to be represented by the following formula: fx a0 n cos n x cosine nx. Here, fx represents the periodic signal, and a0 and nbn are constants, respectively. N represents the frequency component. This formula decomposes the periodic signal into frequency components. This law has a very important theoretical application. For example, Fourier transform converts a signal from a time domain to a frequency domain. This transformation allows you to analyze the frequency components of the signal or extract the required frequency components. This allows you to process and analyze various signals such as music, voice, image, and video signals. Other than this, the law on thermal conductivity, heat transfer area, temperature, gradient. There are various laws of thermal conductivity, heat transfer area, and temperature gradient, but the most basic of them are as follows. Fourier's law of heat conduction. This law describes how much heat transfer takes place in a material. According to the law, in a heat conductor, the amount of heat transfer per unit time, Q, is proportional to the product of the temperature difference delta, T, the thermal conductivity K, and the heat transfer area, i.e. Qk delta T d, where d is the length perpendicular to the direction of heat transfer. Surface temperature gradient law. This law relates the temperature gradient and the heat transfer rate on the heat transfer surface. By law, the heat transfer rate per unit area at a surface is proportional to the temperature gradient of the surface. This law is used to estimate surface temperature and heat transfer rate in heat transfer problems. Foster-Neumann law. This law is used to calculate the thermal conductivity in a multidimensional heat transfer problem. According to this law, the thermal conductivity K of a three-dimensional heat transfer is proportional to the sum of the reciprocal of the heat transfer areas in the three axial directions. For example, if the heat transfer area is in the x, y, and z axes in a rectangular heat carrier RAX, AY, and AZ, respectively, K is calculated as K11K, X, 1K, Y, 1K, Z. These laws are very important in heat transfer problems and are essential for understanding and solving heat transfer